Hey there, my name is Dan Friedman. I'm a data center solutions engineer at Cisco. And today I wanted to spend some time talking about Splunk. Um, Cisco acquired Splunk a couple years ago, I think. It was one of the most expensive acquisitions in the history of our company, if not the history of the world. And there's a reason that we did this that might not be evident on the surface, but I'm sure will be evident by the end of this presentation. I work in the data center space, and so tend to work on a lot of network and compute equipment. I have some sense of what Splunk is. If you're in the data center space with me, then you may have some sense of what Splunk is, but you may not, right? And it just depends on your personal experience. So we're not going to get into Splunk architecture or terminology or usage, at least not very deep. In this presentation. So if that's what you're looking for, then that is not this presentation. What we're going to cover here is really try to explain why Cisco acquired Splunk, why we need it, and the benefits that it can bring to really complex environments, which is what you'll find in a traditional or typical data center. So, I don't get paid on Splunk, but I see this as an absolutely critical tool, given all the data center infrastructure equipment that we have to manage. So let's start the conversation by highlighting the needs of AI workloads. And, I know it's hard to hear a presentation these days without hearing the words AI or the letters AI, but rest assured, this isn't a presentation about artificial intelligence. It's just that the infrastructure requirements that artificial intelligence demands in order to function properly and to function well provides a really great backdrop or context for the Splunk conversation that I want to have in this presentation. So we have two primary types of workloads with AI. Those are training and inferencing. So training is where we use massive amounts of data to train our own AI models. And the process of training requires very high throughput. And that means that the network has to be able to deliver truckloads of data from our storage to the AI model during training very, very quickly. Okay. And then we also have inferencing workloads. So that's more like after the model has been trained, this is where users are consuming an AI model via some application interface. The most common example being like a chatbot, like a chat GPT type interface. And this demands low latency because we don't want our users getting frustrated by waiting around for responses for too long. Okay, so very simple introduction. And Cisco's Secure AI Factory is one such environment that you can use that will address the needs of both of those types of AI workloads, training and inferencing. Okay, now it's not the only environment. It really depends on what your customer is trying to do. If they're just dipping their toes in the water with artificial intelligence, they're not going to require a Cisco Secure AI Factory. Okay, they can get started with a couple of traditional C-series rack mount servers with some GPUs inside them, or they can get started with a couple of X-series blades and the X440p or the X580p GPU nodes inside of a 9508 chassis. Okay, in other words, Cisco Secure AI Factory is a pretty robust environment meant for large-scale AI projects or very demanding AI projects, and it's the full stack is not necessary to just get started dipping your toes in with AI. Okay, this isn't going to be a presentation about Cisco Secure AI Factory either, but again, it provides a great background or context for the conversation that I want to have about Splunk, and you're going to see why very soon. So let's start by breaking down the components of a Cisco Secure AI Factory, and there are many, which you can see on the slide, right? So starting at the bottom, we have many different options for storage, right? And this depends on the performance that you may want to achieve, the scale that you may want to achieve, whether you are open to understanding the differences in the offerings at a storage level, and potentially selecting a new vendor that you haven't used before because they bring something specific to the table that your AI use case requires. So, we have lots of options for storage, and it may also play into, existing relationships you have with your storage vendors and skills that you have in house. So the bottom line here, and really this is true at every layer, the bottom line here is that we want to offer our customers optionality, flexibility to meet their needs, their specific needs. Okay, so we've got lots of options for storage. Above that, we have options for compute, including different options for GPUs and network interface cards that are very important when we are building large multi-node GPU clusters. Above that, we have options for networking, and that's referring to the network itself. So, at Cisco, we have Nexus 9K hardware running either NXOS or ACI operating systems. We also have Nexus Hyperfabric, which is a cloud managed solution. So, there's some decision making that needs to happen there depending on whether you want to manage things using an on-prem management platform or a SaaS-based platform. Above that, we have options for the operating system, which can be installed directly on the bare metal, or it could be a hypervisor or an orchestrator that's installed on the bare metal. And then above that, we have AI software, which could be things like NVAIE or could be open source. So if I click, then I can remove all the specific options and just categorically summarize what the main components of a Cisco AI factory are. Okay, and then to the right of all of that, we have security systems surrounding the technology stack to ensure that it's secure. I'm not going to speak to anything under the security column that you see in this visual. I'm also not going to speak to Splunk enterprise security. What we're going to do is we're going to focus the conversation over on the right, the AI observability piece. So Splunk Enterprise or Splunk Cloud are options that you have here, right? And the key differentiator there is if your requirements require a dark site, in other words, not connected to the internet, then Splunk Cloud is not an option for you. You've got to go with Splunk Enterprise and deploy on premises. Okay. So taking all of those components, that amounts to a pretty complex stack of technology already. And so with respect to each of those components, what do we need to know about each of them? What are our day two visibility requirements, right? Because, if you can't see it, you can't understand it. If you can't understand it, you can't fix it. And, in a complex environment like this, eventually something is going to go wrong. And that doesn't necessarily mean that it's broken, but it could be a misconfiguration. It could be a failing piece of hardware. It could be, performance is suffering for one or multiple reasons, et cetera. And we need visibility in order to identify where the problem is happening in one or multiple locations and to troubleshoot it and remediate that. So for storage, we need to understand things like IOPS and latency, throughput, our capacity, disk health and error rates, file system mount status, etc., right? From a compute perspective, generally speaking, we need to understand the CPU utilization and memory on our server, as well as the temperature that it's operating at and how much power it's consuming. And then, when we install GPUs into that compute, we have additional things we need to understand, like the GPU utilization, the memory utilization on the GPU, so VRAM, the temperature that the GPU is operating at contributes significantly to the temperature of the server overall, and as well as a power draw, any error conditions. You want to understand the interconnect health, right? So how GPUs may be communicating with other GPUs in the same system over something like NVLink, okay? And then we have the network. So at the network layer, we need to understand our throughput and our latency, as I said at the beginning of the presentation, right, based on our AI workloads. Training is very sensitive to throughput. Inferencing is very sensitive to latency. Both are sensitive to packet loss. We need to understand our interface utilization, any errors or discards. We need to know if our links are up. And then at the compute level, as I mentioned, right, you may install your operating system on bare metal, or you may install a hypervisor on the bare metal or an orchestrator on the bare metal. And so I'm kind of mixing some information here, but there's different tools that you can run depending on which of those scenarios applies to you. So if you've installed an operating system like Linux directly on bare metal, then you're still going to be looking at things like CPU and RAM utilization using tools like Top. IOstat will kind of tell you more about what the storage is looking like. NVIDIA SMI will tell you about your GPU utilization, etc. If you've installed a hypervisor, then things that you're concerned with understanding are both the hypervisor and guest OS level resource consumption. Same things here, right? CPU, RAM, IOPS. You may be passing a GPU from the host into a particular virtual machine. You may be splitting a single physical GPU across multiple virtual machines. So what does that all look like? What's the GPU utilization, etc.? And then you could be installing an orchestrator, something like Kubernetes, in which case you may be using kubectl in order to identify, utilization, cluster status, etc., and so on. And then you've got AI software, right, which we mentioned earlier. So this is where you get concerned about things like driver versions and library versions and software versions, and making sure that basically everything is compatible. So that is a lot of visibility needs. And so how do we get all this information besides some of the tools that I already mentioned? Okay, and I did mention a few. So this is where our management tools come in, right? Each one of these layers has its own management tool. So if we look at storage, depending on the vendor, you have different management platforms. You might be using Pure One, you might be using ONTAP with NetApp, you might be using cloud storage if you're in the cloud. For compute, at least at Cisco, we have Intersight for managing all of our compute. For network, you have Nexus Dashboard. You've got Nexus Dashboard Insights, which provides a lot of performance visibility. If you're running Hyperfabric, you've got the SaaS platform that provides visibility. From operating system perspective, like if you've installed a hypervisor, you might be using vCenter. If you're in a Nutanix environment, you might be using Prism. If you've installed an orchestrator, you might be using OpenShift. And if you're looking for basic performance metrics collection, you might be using tools like Nagios or SolarWinds. And then I already mentioned AI software. You've got NVAIE or open source software. And let's not forget security components that we want to wrap around all of this, right, to make sure it's secure. So you've got things like AI defense for putting guardrails around our models to direct appropriate usage and avoid misuse of AI. And then we have other products that fall under the management domain of security cloud control, such as Hypershield, Smart Switch, and our perimeter firewalls. So in translation, we have a lot of infrastructure layers, and with each one of those layers, we have independent tools that enable us to achieve configuration, visibility, and assist us in our troubleshooting efforts. Now, on this slide, I've tried to combine all of those tools into the management tools bubble that you see at the top here, okay? And so just think of this for a minute. Each one of those tools, and there are many inside that box now, right? One or multiple for each of the layers that I talked about. Each one of them generates logs, metrics, and traces. So what are those things, right? Logs are things like event and error messages. So if you think of like logging into a typical switch, like a Cisco switch, you can do show log, and you'll see, protocol, routing protocol adjacencies being formed. You'll see interfaces going up and down. You'll see error messages, and so forth. Okay. And then metrics are really based around performance measurements. So continuing with the network example, these are going to be things like, bandwidth and latency and jitter, right? And then traces help you understand request flows and dependencies. So you can kind of imagine maybe like an e-commerce transaction has to flow through several different systems. And so, that one transaction that you're doing actually touches many different systems. So how do we know which systems that transaction is touching and in which order? Okay, and that's what traces will help you understand. And so, get this, in order to handle these logs and metrics and traces, guess what we need? Oh my God, we need more tools, right? So for logs, we have tools like Prometheus and Grafana and Telegraph. And for metrics, we have tools like OpenTelemetry. And for traces, we have tools like Elasticsearch and FluentBit. So hopefully now you understand the complexity that we're trying to manage, and you can see why I used AI workloads and the underlying infrastructure that those workloads demand. And you can see why I used Cisco Secure AI Factory as the infrastructure supporting those AI workloads. It's because together they help explain my problem statement, which I'm showing here. Okay, so number one, we have too many layers of infrastructure and associated management tools. The problem is each one of these layers and management tools has a role to play, right? They're all necessary. But, for each layer, you've got to install, you've got to configure, you've got to upgrade, you've got to patch, you've got to troubleshoot. And you have to do that not just for the infrastructure, but you have to do that also for the management tools. And then on the previous slide, I said, oh my God, we need more tools, right? That's our intelligence tools. We have too many of those. But just like the infrastructure layers and management tools, they are necessary, right? They have a role to play, and they provide us visibility that we need. And for each one of those tools, you need to install, configure, upgrade, patch, troubleshoot. This is a mess, right? And then you consider that different infrastructure components generate different metrics, right? So in a storage system, you're interested in IOPS, but in a network system, IOPS isn't really a thing. You're more concerned with things like latency, right? So the infrastructure is not uniform in the information that it's generating. And then, you consider the applications that are running on the infrastructure, and, each application could be written in a different programming language. And even if they're not, they could still be generating different log formats, and different applications have different dependencies and systems that are participating in the delivery of that application. And so the traces that they generate are going to be different, right? So we have basically no standardization, okay? And in translation, right, that means that we have, let's start with multiple operations teams or silos that are all managing this infrastructure, right? So you've got a network team, and they're responsible for the network infrastructure and the network tools. And maybe you've got more of a platform team that's responsible for the intelligence tools. But the bottom line is you don't have a single person managing all of this stuff. So you have different areas of expertise and different areas of infrastructure, tools, and responsibility. Okay. Next, you've got multiple sources of data. That should be pretty evident from what we've been talking about. You've got multiple systems, and as I was indicating, right, you've got no standardized formats. And as I was saying, right, every one of these things are necessary. They have a role to play. And so it's sort of like saying everything is top priority, and so nothing is. You guys have heard that statement before, right? So the question then becomes, how do we solve this gigantic mess of infrastructure layers, management tools, system dependencies, uh, different metrics being generated, different log formats and traces that our workloads provide? And well, you guessed it. The solution is Splunk, right? And this is exactly why Cisco purchased Splunk. It was very strategic purpose. Why? Because the environments that we are dealing with are becoming increasingly complex, and Splunk helps us simplify that complexity. So I'm going to pause. I'm going to give you a moment to read the quote on the screen, and then I'm going to resume talking. So I'm just going to wait here for a minute. Okay. So as you just read, right, Splunk is trying to become the single destination for all of this visibility information that we need. And since all of that is sourcing from the multiple different layers, uh, this should provide top to bottom visibility to your entire stack of technology. Now, the way that we do this is through a telemetry pipeline. So first we collect the data on each of the individual devices, and then we transmit that collected data towards Splunk. So, if you're an old network engineer like me, then we used to configure all of our network devices to point at our syslog server. And now we still have to do that in this environment, but it's not just the network, it's on all the devices, right? Not just the network devices, our hosts, our compute nodes, our storage nodes, our network devices, everything should be sending its logs, metrics, and traces towards Splunk. Once the data arrives at the Splunk system, then it gets stored. And once the data is stored, then we can analyze that data. When the analysis is complete, we can then use it to visualize the information and report on that data. So what do we stand to get out of Splunk by doing all this? And so on this slide, I've tried to highlight the benefits, right? So we can correlate the logs from multiple systems to get a more complete and coherent picture of exactly what the system is doing or not doing under the hood to deliver the results that our business applications expect. We can more quickly drive towards and identify the root cause of problems when we're troubleshooting. We can optimize performance, right? So for example, when you hear latency, you normally think of networking, but the truth is latency is a problem in every component of a system. And in order to maximize performance of a system, we have to drive latency out of every component in the system. And that means that we need to be able to see every location in the system that is contributing to latency and how much it's contributing, right? So that we can focus our efforts in the areas that are, we can prioritize where to begin troubleshooting latency, right? Which offenders, some areas of the system are going to be worse offenders than others, and we want to target those systems or those areas first. But with all the data in one place, we can now understand how much latency exists at every point in the system. We can proactively detect issues. So again, with all of this data, we can baseline behavior, we can understand trends, we can see like when disk capacity is running out, we can see when latency is starting to creep up, and we can do something about these problems before they become major problems, right? Create application outages or hundreds of support calls coming into the help desk. And of course, we have a complete record of all the activities occurring across our entire system in order, which helps us meet our compliance and audit requirements. Now, All of this requires precision time protocol. Why? Because if things aren't in order, then we can't really understand what actually happened, right? Imagine you have a process where A happens before B, but in your system logs, the activities occurring on B are showing up before the activities on A, and that's just not the order in which things are executing from a process perspective, right? So if your logs aren't in order, then you're going to have a really hard time troubleshooting. Okay, you're basically guessing. So PTP allows more granular precision with respect to the timing of events across our entire system, across all of the individual elements participating in that entire system. And that's really needed in a high performance compute and AI environment where things are happening very, very fast and efforts are highly coordinated. All right. So if you think about training an AI model, then you have to feed data from the storage system across the network to the compute, which contain the GPUs. And the data set is so large that you're basically submitting that data set as a batch job to a huge number of GPUs running across multiple nodes. And those GPUs are essentially splitting up the work amongst themselves, but this is a highly coordinated effort, right? Everyone has to stay in sync with everyone else about, well, which chunk of work are you doing? You know, who is doing what? When is that happening? And they all have to wait for each other to finish their pieces of work before they synchronize the results with each other. So how could this highly coordinated effort occur if the systems involved can't even agree on the time? And the answer is they can't, right? So that's why this requires PTP. Okay, so accurate time in such an environment is absolutely critical in order to help us correlate logs across services, right? So each independent system contributing to the overall results submits its logs. Those are all now centralized on the Splunk system, which means we can correlate events across the systems to put together a better picture of everything that's going on and how each individual element is coordinating in that effort. Okay, we can reconstruct sequences of events across those multiple systems. Again, who did what when. We can debug latency and performance issues. So we need the granularity of being able to see which component of the system held responsibility for taking action and for how long. And that's why we need a PTP for that granularity. And then triggering alerts based on time-based patterns. So maybe too many events in X period of time. And so we're going to fire off an alert, right? And then, as I mentioned, right, coordinating actions across multiple systems like GPUs and storage and compute network, everybody's participating all at the same time. Okay, so hopefully that gives you a clear picture of why Cisco purchased Splunk, why we need it, and the problem that it's solving for us in the data center. If you need to dig in deep on Splunk, then feel free to reach out to me and I can connect you with somebody on our Splunk team. Thanks for taking the time to watch. I hope this was helpful. Thanks.